If I could have your attention, I'd like to cover some items about mathematical discourse. You guys are doing a great job working, but I could have you in separate rows working individually for the lack of conversation I've been hearing. Here I have some prompts about useful team conversation starters. I expect to hear you talking about math, so I need this list read. Would you start here and go across the rows?
What if we tried blank?
I have another approach to the problem. How about blank?
I'm not sure that will work because blank. What if we tried blank?
Can anyone suggest a different approach?
I like your idea that blank. Could you please explain that another way?
Okay, are there other ideas that could start conversations in your teams? Jane?
I hear you saying blank. Is that right?
Okay, I hear you saying blank. I'm going to abbreviate that right here. Amy?
Are we all in agreement?
Are we all in agreement? That gives students who are not agreeing with you the opportunity to speak up in case they've been timid. What a great idea. Yes.
Your idea gave me this idea.
Okay, your idea gave me this idea. Okay, as you get back to work, note that I'm listening for these kinds of things and I'll be looking for them in your conversations. Get caught saying them.
I finished mine.
Me too.
It ends up the two interior angles add up to 180 degrees.
So can we all agree that they're parallel? The lines are parallel?
Yeah.
No, I'm not understanding why that makes it parallel though.
Okay, here, I'll show you. Can I borrow your pencil, please? If the two lines are parallel and the same side interior angles equal 180, then they will never touch. But if they're anything different than 180, they will form a triangle or a third angle.
Because triangles have 180 degrees.
But if the sides are already equal to 180, there's no room for a third angle, so they'll be parallel.
Yeah, that makes sense.
All right.
Alright, so we should start by setting up a blank proportion.
I think in the first proportion, he uses 7 tubes of toothpaste, so 7 would be on top, and then 10 months would be on bottom, so 7/10.
Okay. And then for the second proportion, or for the second one, since time was on the bottom in the first one, it should be on the top in the second one, so it should be like 5 over x, because we don't know how many tubes of toothpaste to use.
Okay, yeah, that makes sense.
Okay.
Wait, I don't think we're setting this up right. I mean, we can solve it and then go from there, like, to see if it's correct or not, but...
I solved it, and he would use 7.1 tubes of toothpaste.
Which, that doesn't work.
Yeah, that wouldn't work, because why would he use only like 0.1 more tubes of toothpaste for 5 years than he does in 10 months? Like, that just doesn't make sense.
Like, I think that we messed up because we didn't... Okay, like, in the first proportion, we put the time on the bottom, and then in the next one, we put the time on the top instead of on the bottom. Like, it should have been the same, you know?
Mm-hmm.
Like time, like tubes of toothpaste both on top, and
then the time on the bottom.
Okay.
And also, the 5 years doesn't, like, equal the 10... Or it's not in the same units as the months.
So you need to convert
like-
years to months?
Yeah.
Okay.
So,
Okay, so you're saying we should set it up like 10 or 7 over 10 equals the variable over
60.
60.
So that's 60 months in 5 years. Okay.
Yep.
And if you
If you work that out, you get...
42?
Yep.
Okay, that makes a lot more sense.
Yeah.